August 6, 1945. The United States drops an atomic bomb on the Japanese city of Hiroshima. 3 days later, they do the same in Nagasaki. The power of nuclear energy is demonstrated. Both cities and their populations are decimated. Out of the ruins of World War II, two superpowers emerge. The Soviet Union and the United States are now in a race to harness nuclear power.
The Cold War after 1950s was about the nuclear arms race. And the #1 driver in the nuclear arms race was technology.
It was an unprecedented militarization of both sides, which changed the perception of how much you can spend on defense.
Atomic and hydrogen bombs and intercontinental ballistic missiles. Nuclear power that fuels invention, weapons proliferation, and purpose beyond destruction. The Cold War, a decades-long struggle between two superpowers and former allies, the United States of America and the Soviet Union. But beyond the ideological divide of capitalism and communism was a battle of another kind, one for technological supremacy.
And for each of these systems, science and technology were critical for how they were going to thrive and grow and bring prosperity and justice for their people.
Experimentation with nuclear power, innovation of weapons technology, exploitation of science capabilities.
The entire space program, you could argue, was a creature of the Cold War.
A race for scientific supremacy that lifts humanity beyond Earth's atmosphere, drags the world to the brink of nuclear annihilation, and launches decades of research into scientific and engineering marvels that continue to define the modern world. (1945). War has raged across Europe for 6 long years. In January, the horrors of war are made real as prisoners from Auschwitz are liberated. In April, Soviet forces capture the German capital of Berlin. Italy's fascist leader, Benito Mussolini, is dead, executed by his own countrymen. Days later, Germany's leader, Adolf Hitler, takes his own life. By May, Germany surrenders unconditionally. The war in Europe is over. But in the Pacific, the fighting continues. Allied forces may have turned the tide against the once seemingly unstoppable might of Japan. But Japan does not surrender.
They're not allowing themselves to be taken prisoners. They're dying to the last man. So it looks like if you're going to invade the Japanese home islands, and that was the plan in September 1945, you might take 500,000 casualties.
Allied leadership determines that a swift and decisive conclusion is better than an ongoing and costly invasion of the Japanese mainland. The United States President, Harry Truman, sanctions the use of a new weapon, one that has been in development for the past 6 years. August 2nd, 1939. A letter arrives on the desk of then U.S. President Franklin D. Roosevelt, co-authored by fellow physicist Leo Szilard and signed by theoretical physicist Albert Einstein. The letter warns of Germany's advanced research into fission chain reaction.
It all begins with Einstein's letter. Now, a couple guys, particularly Leo Szilard, who's a Hungarian Jew, went to see Einstein at his home in Long Island. And the only way to capture the attention of the president in 1939 was have the most famous scientist in the world write a letter to the president, where he says the Germans have made a breakthrough here, and it's possible that because of the fission in the uranium to deliver great explosive power.
Just to give you an idea, one fission event produces 10 million times the energy of a chemical reaction.
Here, experiments with primeval atomic power led to the splitting of the uranium atom, force of the cosmic bomb.
Not every atom can undergo fission, only some can. And even for those that can undergo fission, it is often not a spontaneous reaction, but requires an initiating event. For instance, the absorption of a neutron. So if you get a heavy atom, that's pretty much anything in the bottom half of the periodic table, and you throw neutrons at it, probability is that they will absorb the neutron. A small subset of those atoms, after absorbing the neutron, would decide to split in two, and that's fission. Uranium-235 and plutonium-239 are two such atoms that behave like that.
That such a bomb might be used against American targets, ports, cities, and military bases, persuades Roosevelt to fund a nuclear weapons research and development program, the Manhattan Project. In Lower Manhattan, in federal office buildings on Broadway and Chambers Street, U.S. Army Corps engineers begin coordinating the atomic bomb project. General Groves, the project's director, appoints a young physicist, Julius Robert Oppenheimer, to lead the project's secret weapons lab.
You couldn't invent these guys. You get General Groves, who built the Pentagon, very stern type guy, sort of an administrator. And he appoints a left-leaning American physicist, Robert Oppenheimer, is in charge of the project. You got all these left-wing guys who are being then poached by the American government to develop a nuclear weapon before anybody else does.
For added security, away from public scrutiny and prying eyes, the Manhattan Project transfers the lab to Los Alamos, New Mexico.
These guys are working 6-7 days a week. After a while, they're working around the clock. That is, they have different teams working on it. We got people in Tennessee working on the uranium. We got people in Washington State working on producing plutonium, and there isn't much of either one of them around. And they had something that the Germans didn't have. They had a blank check. And they had the best scientists in the world all concentrated in one place. And technological people, that is, people who could build bombs, started to work together. Chemists, engineers, theoreticians, etc.
Once upon a time, men of science were preoccupied with the task of transmuting metals into gold. Now, we hope, the modern alchemists are proceeding with the job of using atomic knowledge for the benefit and not the destruction of mankind.
July 16th, 1945. The world's first atomic bomb is tested in the New Mexico desert. The result of the combined efforts of the United States, Canada, and the United Kingdom, the weapon, nicknamed the Gadget, releases an explosion the equivalent of 20,000 tons of TNT. The blast all but destroys the 30-meter-high platform from which it is dropped and creates a mushroom cloud that reaches 12 kilometers high. Just a few years after the Japanese attack on Pearl Harbor and Roosevelt's declaration that the United States enter the war, the atomic bombs born from the Los Alamos laboratory descend upon Japan. First in Hiroshima, then in Nagasaki. The bomb that explodes over Hiroshima is dubbed Little Boy, while the one dropped on Nagasaki is called Fat Man. Both deliver instant devastation on an unimaginable scale.
The two weapons relied on the same principle of trying to create a critical mass of fissile material in as little time as possible before it would detonate and explode into many pieces.
Little Boy is a 4,400 kilogram, 3-meter long, 70 centimeter in diameter gun-type nuclear weapon. Two separate portions of uranium-235, a target and a projectile, are fired into each other, triggering a chain reaction.
The bomb that was used in Nagasaki, also known as Fat Man, relied on an implosion type. In an implosion type device, you have a sphere of your fissile material that is surrounded by conventional explosives that are carefully arranged in such a way that if you detonate them all at the same time, they compress the sphere of fissile material and they get smaller and smaller and smaller at the point where it can reach critical mass. And in the middle of that sphere, you would have the initiator, which would start producing neutrons as it gets compressed. And the initial shock wave that compresses the plutonium sphere is also what stops it for a fraction of a second to explode out.
It is an atomic bomb. It is a harnessing of the basic power of the universe. The force from which the sun draws its power has been loosed against those who brought war to the Far East.
The destruction wrought by these new technologically advanced weapons is without precedent. In Hiroshima, 70,000 out of 76,000 buildings are damaged or destroyed. Civilian casualties are immense, and continue to climb months after the initial explosions. August 15, 1945. Emperor Hirohito announces the surrender of Japanese forces. The Second World War is over, and the atomic age begins.
They were defeated by modern science. So modern science allowed the Japanese a face-saving gesture to get out of the war. In the end, they were defeated by technology. And the lessons of that technological defeat carried straight through to the Cold War.
Will this power, now available to man, bring another, even more suicidal war upon us? Or can it be made to rule out war and open a new, progressive chapter of history, the atomic age?
The United States is now the sole superpower in control of this devastating technology. But power is always tested. The British, German, and Americans are engaged in nuclear programs years before the US bombing of Hiroshima and Nagasaki. So too is the Soviet Union. Soviet leader Joseph Stalin had been convinced by Russian physicists of the necessity of pursuing the development of a uranium bomb.
The explosion of American nuclear bombs in Hiroshima and Nagasaki caused the Soviet Union to begin a crack program to produce its own nuclear weapon. The design was stolen by Russian Soviet spies.
Though minuscule when compared to the Manhattan Project, the Soviet program accelerates in the years after the conclusion of the Second World War.
You know, at the end of the war, the Soviets grabbed as many scientists as they could, German scientists. So, you know, they knew as much about splitting the atom as anybody else did. The trouble is, would they have the technological ability to do something about it?
The problem was not so much the design as the creation of an industry that could produce arms-grade uranium, arms-grade plutonium, and a lot of other components that are needed to make a practical nuclear weapon.
Under the direction of physicist Igor Kurkatov, the Soviet program to develop an atomic bomb operates out of Laboratory Number 2 on the outskirts of Moscow. The program grows rapidly with the onset of the Cold War, expanding from 650 staff in 1946 to 1,500 in 1947. Secrecy is paramount. Documentation lists the lab as an assembly workshop, and employees are subject to complex security checks. August 29, 1949. The Soviets detonate their plutonium-based implosion-type atomic bomb, the RDS-1, also known as First Lightning, at their testing ground in Kazakhstan. A 22-kiloton yield delivered in the blink of an eye. September 3rd, a U.S. Air Force B-29, specially fitted with filters designed to detect radioactive debris, travels from Japan to Alaska. It detects levels of radioactivity marginally above the threshold that would dictate further investigation. More samples are collected. They reveal an unsettling truth to the international intelligence community. A Soviet nuclear test has taken place.
After the discovery of Soviet nuclear capability in August 1949, forced the Truman administration to think about how to move forward in the future. And most importantly, it was the end of American nuclear monopoly. So then we enter a new stage.
The stunning news bursts on America. John Q. Citizen wonders what happens now.
April 14th, 1950. President Truman receives National Security Council Paper Number 68, a document that will go on to shape U.S. Cold War policy for decades.
It's a document written by Paul Nitze, who was the co-author of the Strategic Bombing Survey after World War II. Nitze argues Soviets had probably acquired a nuclear weapon, and then he says something very important that did not change for the entire Cold War. He says once they have a chance to deliver this, they will. So he always argued that once the Soviet Union had acquired a certain technological superiority, they would use it first.
And so the point of NSC 68 was to say we have to fight this war in every possible way that we can and build up our arsenal in every possible way that we can, precisely so that we don't have to use it.
As communism continues to gain a foothold in China and Korea, The fear Americans have of Soviet communist expansionism is palpable.
And so this document's actually going nowhere until the North Koreans attack the South Koreans, which makes all the people behind NSC 68 look like geniuses because they say the Soviet Union is probing, waiting for the right moment.
June 25th, 1950. Troops of the North Korean People's Army crossed the 38th parallel into South Korea, starting the first military conflict of the Cold War.
I think it's also worth noting that the Cold War was anything but cold. Imagine telling that the Cold War was cold to the inhabitants of Vietnam, Korea, Afghanistan. These people knew full well that the Cold War was also a stage for seeing out a series of hot military action.
The North has support from the Soviet Union and Chinese Communist forces. South Korea is backed by a United Nations force comprising mostly of the United States military.
If the United Nations yields to the forces of aggression, no nation will be safe or secure. If aggression is successful in Korea, we can expect it to spread throughout Asia and Europe and to this hemisphere.
After South Korea is attacked, NSC 68 becomes a policy. That is, the word goes out that this is what we're going to follow. And it becomes the most formative, seminal national security paper ever written because it controlled how the money was going to be spent for the next 10 or 20 years, particularly getting a thermonuclear weapon.
Truman directs scientists of the Los Alamos facility to focus their attention on a weapon that would make the death toll in Hiroshima and Nagasaki appear minuscule by comparison. The hydrogen bomb is coming. Atomic bombs use uranium or plutonium and rely on fission, the nuclear reaction that cleaves an atom in two and triggers the chain reaction. Hydrogen bombs similarly use uranium or plutonium in the first phase of the reaction, but additionally harness the intense heat generated by this to trigger a second phase, which fuses hydrogen isotopes deuterium and tritium to create helium.
The challenge here is that the two atoms that you start with are repelled by the positive charge inside them. So you have to accelerate them to incredible energies in order for them to collide and not bounce around as they normally would, but actually overcome the repulsive force and then fuse together. The amount of energy that can be released through fusion is really quite large, but it is technically much, much harder to achieve enough energy to initiate the reaction. So in the case of a weapon, the starter for a hydrogen bomb is actually a nuclear bomb. So in the same way that a nuclear bomb uses conventional explosion to start it, in a hydrogen bomb use conventional explosions to start a nuclear bomb, which then produces enough energy to start a fusion bomb. The yield of a fusion bomb is much, much greater than that of a fission bomb, and I can only say we are lucky we've never seen the effects of a fusion bomb on a human population.
The United States hope this weapon will reinstate their lead in the nuclear race. November 1st, 1952. The first hydrogen bomb is tested near a South Pacific atoll in the Marshall Islands as part of Operation Ivy. A thermonuclear explosion 1,000 times more powerful than the bomb that destroyed Hiroshima. And they don't stop there. Over the next few years, the United States continue thermonuclear tests in the South Pacific Marshall Islands.
With nuclear weapons research, the emphasis was always on speed. The emphasis was on yield. The emphasis was on damage. It was never on safety. And for the Atomic Energy Commission, the organization that ran the atomic tests, the consensus was that whatever damage there was, the risks of damage from fallout were less than the risks of losing to communism, were less than the risks of nuclear war.
Operation Ivy is followed by Operation Castle, a series of 6 tests, the largest of which, Castle Bravo, fueled by lithium deuteride, explodes with a yield of 15 megatons.
The yield of this bomb was much larger than the United States had anticipated, so much so that Marshall Islanders could never return to their homes.
There were 2 mistakes on that day. Number one, the test was much greater than they thought it would be. In fact, it sank the island that it was tested on, sank all the damn equipment. And the second thing is the wind was blown in the wrong direction. It created a great deal of radiation in the ocean.
The effects of the blast travel much further than anticipated, and the unfortunate crew of a Japanese fishing trawler called Lucky Dragon, some 128 kilometers from the site of the test, also experienced radiation sickness.
When the public saw what had happened, the Atomic Energy Commission denied that there was any damage and said, no. Fallout is safe. Nuclear testing is safe. But 1954 was really the first moment that the public at large said, we don't trust you. We don't agree with you. Nuclear testing is not safe.
While the successful testing by the United States of thermonuclear devices momentarily restores a sense of security for the American people, in August of 1953, the Soviets pull that rug out from under them. They conduct their own nuclear tests, one of which, RDS-6, consists of alternate layers of hydrogen fuel and uranium. Its design is inspired by the layered design of a puff pastry, Slaka. With a yield of 400 kilotons, the test is more powerful than previous Soviet tests, but falls short with American comparisons. But this proves the Soviet Union is still in the race, with a deliverable weapon that can be deployed from a plane. Throughout this, the Korean War continues, a costly campaign languishing between stalemate and negotiation. It had been U.S. President Harry Truman that ordered U.S. air and naval forces to repel the North Korean invaders. But by 1953, he is out of office, and Dwight D. Eisenhower is sworn in as the next American president. Eisenhower indicates to his administration a readiness to use nuclear weapons to break the deadlock in Korea, if required.
Eisenhower made it very clear that he would use nuclear weapons, and that scared the hell out of a lot of people, because if you're going to use nuclear weapons against a superior conventional force, then what's the bottom line there?
Man's greatest scientific achievement, therefore, cannot yet be made exclusively to serve the advancement of man's welfare and happiness. Instead, we are forced to concentrate on building such stores of armaments as can deter any attack against those who want to be free.
March 5th, 1953. Soviet leader Joseph Stalin dies, creating a power struggle within the Communist Party. One that Nikita Khrushchev ultimately wins when he is named as first secretary of the party in September. While the Soviet Union has been providing material support to North Korean and Chinese forces, this is no longer necessary by the time Khrushchev comes to power. July 27th, 1953. The Korean Armistice Agreement is signed, bringing an end to hostilities. The conflict may have ended without the deployment of nuclear weapons, but it awakens in North Korea a desire to build and proliferate their own nuclear weapons program. As the arms race continues, both sides look to increase their nuclear capabilities by developing improved delivery systems.
The problem was, how do you strike the Soviet Union with anything other than a manned aircraft?
Short-range ballistic missiles launched within Earth's atmosphere are one way of delivering a nuclear warhead from afar. While intercontinental ballistic missiles, or ICBMs, travel into Earth's suborbit, allowing for the potential of even greater striking distance.
The advent of the ballistic missile allowed the United States, also allowed the Soviet Union to strike targets rapidly, and then over time to strike those targets very accurately as well.
This ability to launch nuclear warheads from great distances is something the Soviet Union believes is vital to their national security.
Well, Russians developed their own nuclear weapon that took some years, but it was developed. Then there was a problem of delivery systems. And Russian bombers would have a hard time reaching the United States. So that means the Soviet Union began investing heavily into building intercontinental missiles.
Both the Soviet and American long-range ballistic missile programs evolved from the German V-2 liquid propellant rockets of World War II. August 21st, 1957. Soviet scientists conduct the first successful launch of the R-7 Semyorka, the world's first intercontinental ballistic missile. 34 meters long and about 300 tons in weight, The R-7 is powered in stages by rocket engines that mix liquid oxygen with kerosene. 4 RD-107 rocket boosters achieve the initial launch. A central RD-108 engine maintains power through the first and into the second launch stage. Smaller rocket engines, vernier thrusters, adjust for maneuverability, stability, altitude, and velocity. The missile's trajectory is guided by radio control.
The Semyorka was important. It was the first intercontinental ballistic missile ever deployed, but it was not really an ICBM of any practical purpose. As an ICBM, it was soon scrapped because it used liquid oxygen, and that means you couldn't keep it for a long time ready to go. And also you couldn't put it into a silo. It was standing just in the open. That means very vulnerable.
In missile technology, the R-7 Semyorka is a first for the Soviets in the Cold War tech race. This successful launch comes a month before the US successfully tests their Atlas ICBM, a program that has been running concurrently to that of the Soviets.
Project Atlas was the program to field the first US intercontinental ballistic missile. And that meant that it was a program to do something that had literally never been done before. Take a missile, launch it up through the atmosphere where it was experienced shaking, heating, out of the atmosphere as the Earth orbited underneath it, and then have the re-entry vehicle re-enter the atmosphere, and to get that payload to land somewhere close to where it was intended.
The project is given unprecedented funding and becomes the nation's highest research and development priority, costing an estimated $8 billion.
President Eisenhower made clear that money was not an object, but time was of the essence. And so as a result, all the different parts of the Atlas had to be developed in parallel. So Project Atlas was a huge effort in not just developing new technology, but also integrating those different technologies.
Both Cold War superpowers now have intercontinental ballistic missiles that can deliver nuclear weapons, thermonuclear warheads, chemical or biological weapons. Inspired by the German V-2 rocket, variations continue as designs and modifications evolve. Missile technology now fuels these Cold War adversaries to greater heights. In October of 1957, the world's first satellite, Sputnik, is launched into space by a variation of the R-7 Semyorka. The United States is beaten into space, underestimating the Soviet Union's technological prowess. The world and Eisenhower are caught off guard.
There was an enormous amount that we didn't know about the Soviet Union and its arms programs during the early Cold War. And so when the Soviets launched Sputnik, the first satellite, there was concern that the Soviets had a real lead in missile technology.
Modern weapons like this tell the story of Russia's striking power.
America now takes seriously Khrushchev's declaration that the Soviet Union possesses significant nuclear capabilities.
Khrushchev talked about the Soviet Union turning out ballistic missiles like sausages as a way of hyping their missile program.
Some within the Eisenhower administration are convinced that the United States has a missile gap, that the Soviets have proliferated a nuclear arsenal far exceeding their own. But now, the United States is ready to show off their latest development in missile technology, one that will level the playing field and reassert their Cold War supremacy. February 1st, 1961. The intercontinental ballistic missile, known as the Minuteman, is tested at Cape Canaveral. A 3-stage solid-fuel-burning missile that soars up out of Earth's atmosphere, maintaining a celestial suborbital arc, before returning to swoop back down fast toward its target.
The first generation of intercontinental ballistic missiles, like the Atlas and like the Titan, were liquid-fueled. It took a while to actually put the fuel in the missile, to raise it up, to prepare it for launch. The Minuteman was designed to be fired right away. So the Minuteman was the first ICBM to feature solid propellant, which meant that it was propellant that was stored in the missile itself. And so it was designed for rapid fire.
If needed, they would launch from underground missile silos built across the Great Plains of Central and Northern America. 1,000 metallic beasts standing primed. A hibernating, weaponized herd, ready to launch in an instant. It arrives just in time for the Cuban Missile Crisis. November 1960. President Eisenhower's second term in office comes to an end. His Republican Party successor, Richard Nixon, faces off against an energized young Democrat candidate by the name of John Fitzgerald Kennedy. Kennedy's campaign promises include a more aggressive stance on winning the space race and pursuing nuclear non-proliferation. November 8, 1960. Kennedy wins the election in a close race to become the 35th President of the United States. However, before Kennedy conquers the tech race into space, a threat to America emerges in the form of Cuban leader Fidel Castro. Castro had overthrown the military dictatorship ruling Cuba and nationalized all US-owned property, prompting the severing of diplomatic ties and a trade embargo from the United States. Cuba, located less than 200 kilometers from the American mainland, looks towards the Soviet Union for economic and military support. April 17, 1961. Kennedy approves an invasion of Cuba by over 1,000 CIA-trained anti-Castro Cuban exiles. Kennedy hopes that by overthrowing Castro, he will remove an emerging communist state from America's doorstep and gain an important advantage in the Cold War. The invasion of the Bay of Pigs is both a miserable failure and a turning point in the Cold War. It widens the chasm between America and Cuba, while strengthening Cuba's relationship with the Soviet Union. By the time the Bay of Pigs occurred, America has nuclear weapons installed at bases in Turkey and Italy. The Jupiter, medium-range ballistic missiles armed with a 1.44 megaton thermonuclear warhead, could scorch through the sky and reach all of the Western USSR, including Moscow. The geographical proximity of these weapons facilities so close to Russia does not sit well with Khrushchev.
A decision was made to deploy some combat troops to Cuba and nuclear missiles. Having Cuba as a launching pad for Russian Soviet missiles seemed very important militarily, that this was a game changer, changing the nuclear balance, giving the Soviet Union a handle on the American nuclear superiority.
Cuba wants to prevent another Bay of Pigs invasion. With Kennedy now in office, American U-2 spy planes fly over Cuba and capture the construction of medium and intermediate range ballistic missile facilities.
At United Nations headquarters in New York, the Cuban crisis is the one and only subject of discussion.
Let me ask you one simple question. Do you, Ambassador Zorin, deny that the USSR has placed and is placing medium and intermediate range missiles and sites in Cuba? Yes or no? Don't wait for the translation, yes or no?
Khrushchev argues that like U.S. missile facilities in Italy and Turkey, the presence of Soviet missiles in Cuba is merely a deterrent to American aggression. But Kennedy won't allow it.
The fear during the Cold War is that either side would have a technological breakthrough which would become destabilizing. That is, the other guy would be so convinced that the other guy was going to strike first, that they might strike first.
Robert McNamara, Kennedy's Secretary of Defense, advises the newly elected president that three options exist. 1. Engage diplomatically with Cuban leader Castro and Soviet leader Khrushchev. 2. Encircle Cuba with a naval quarantine, stopping Soviet ships from entering Cuban waters. 3. Decimate the missile sites by air attack, but risk triggering a Soviet counterattack.
They believed that the United States in '62 had such a nuclear advantage, that any nuclear war, America would win. America would also be hit by nuclear weapons, but would survive while the Soviet Union would be obliterated. President John Kennedy didn't want that, and the Secretary of Defense McNamara also didn't.
Intermediate-range ballistic missiles can span a distance of between 3,000 and 5,500 kilometers, roughly 2,000 to 3,000 miles. Medium-range ballistic missiles generally range less than 3,200 kilometers. Clearly, the medium-range Soviet SS-4s that had been photographed by the US being assembled in Cuba, and the intermediate-range Soviet-built R-14 missiles could reach any target within the United States. Fear of nuclear attack is more real than ever before.
What are you supposed to do when you see the flash? Duck and cover. Duck and cover. Duck.
October 22nd, 1962. Kennedy announces to the American people the presence of Soviet missiles in Cuba.
It shall be the policy of this nation to regard any nuclear missile launched from Cuba against any nation in the Western Hemisphere as an attack by the Soviet Union on the United States, requiring a full retaliatory response upon the Soviet Union.
The American public, fearing a nuclear war is imminent, rush to hoard food and gas and find ways to protect themselves from an atomic blast. Across the Great Plains of southern and northern Dakota, Wyoming, and Montana, the Minuteman missile silos power up. The situation is spiraling out of control. Both sides send demands to the other to end the dispute. Castro encourages Khrushchev to attack the United States. October 27th. Khrushchev and Kennedy finally reach an agreement, ending a crisis that brought humanity closer to destruction than ever before. If Kennedy promises not to invade Cuba and remove missiles from bases in Italy and Turkey, Khrushchev will dismantle the Soviet missiles and withdraw from Cuba.
The missile crisis was seen as a Russia stepping down. The Americans also withdraw their missiles from Turkey, but that was agreed that withdrawal will be kept secret. So from the public point of view, it was that President Kennedy stood up to Khrushchev, which was an important factor in his overthrow that happened in 2 years in 64, when there was a kind of a conspiracy and coup to remove Khrushchev, that he turned out to be weak in the Cuban Missile Crisis.
The Cuban Missile Crisis is a turning point in the Cold War. Tension eased, communication prevailed.
So they found a compromise, and the Russian missiles were withdrawn from Cuba, and the nuclear weapons with them, which was a big deal at the time, though in several years the Soviet Union developed and began mass production and mass deployment of silo-based ICBMs, so they didn't really need Cuba anymore militarily that much.
August 5th, 1963. After years of discussion, the Soviets, Americans, and Great Britain take the first step toward nuclear arms control by signing the Partial Test Ban Treaty. It comes at a time when nuclear testing had reached a peak. Previously, on October 30th, 1961, the Soviet Union had tested their RDS-220 hydrogen bomb. The 8-meter-long, 2-meter-in-diameter multi-stage thermonuclear weapon was so large it had to be carried in a specially modified bomber to conduct the test. While similar in shape to the Fat Man and Little Boy bombs, it is estimated to be 1,500 times more destructive than the two combined. Deployed by a parachute, the bomb detonated 3.9 kilometers above Novaya Zemlya, an archipelago in the Arctic Ocean, leaving a mushroom cloud 67 kilometers high. The Partial Test Ban Treaty assures that a bomb this powerful cannot be tested again.
And the Soviets and the Americans are willing to agree to this, along with the Brits. in 1963, and I had a chance to talk to the top American negotiator. And I said, why now? And he said, well, after all the nuclear tests and the three-stage rocket tests in the 1950s and early 60s, the United States knew everything it knew about atmospheric testing, and so did the Soviet Union. So what they agreed to do was to just put it off the table, because they knew everything they had to know.
As the Cold War rolls on, other nations look to enter the arms race by developing their own weapons programs. Initially, the People's Republic of China looked towards their communist ally to kickstart their nuclear research.
The Soviet Union provided technology and know-how to help China develop their nuclear weapon. So that's happened in many cases. Technology exchange with China stopped when under Nikita Khrushchev, when China and Russia became bitter enemies, especially during when China had this border war with India. And by '62, I understand all technological transfer stopped.
As China distances itself from the Soviet Union, the Cold War morphs from a bipolar Soviet-American affair to a tripolar Soviet-American-Chinese standoff. The Chinese were invited to put their signatures on the 1963 Test Ban Treaty, but they declined. In 1964, China tests their first nuclear weapon. Project 596, codenamed Sheik by U.S. intelligence agencies, is a uranium-235 implosion fission device.
Now, the Chinese were very reluctant to acquire nuclear weapons, and the ones that they have today, the ones they developed during the Cold War, were designed what they thought to be a minimum deterrent. What is a deterrent? A deterrent is fear of retaliation.
About 2.5 years later, China tests their first thermonuclear device. Codenamed Test Number 6, this hydrogen bomb was detonated in a dried-up salt lake, Lop Nur. Like China, France too had not signed the Test Ban Treaty. From 1960 on, France conducts over 200 nuclear tests in French colonies outside of Europe, such as the Algerian Sahara and French Polynesia in the South Pacific. Through the 1960s and into the 70s, nations raced to keep up pace with nuclear weapons development. Countries such as India and Pakistan, beleaguered by border disputes or ongoing tensions, continue to develop their own nuclear weapons profile. They, and countries like Israel and North Korea, chose not to commit to the NATO-negotiated 1968 International Non-Proliferation Treaty. Nuclear arms are embraced by countries whose economic, political, and social landscape has altered and grown in the decades following the Cold War. The world is changing. In the wake of environmental catastrophes triggered by nuclear testing, the public is keenly aware of the dangers of nuclear technology. Still, nuclear-powered technology developed during the Cold War becomes an energy source that nations clamor to tap into. Nuclear reactors can provide countries with a zero-emission clean energy source.
A nuclear reactor can really be thought of as an enormous boiler or a kettle. Its sole purpose is to heat up water. Once you have hot water and you can generate steam, it works the same way as any other thermal generator. In the core of the nuclear reactor, you have nuclear fuel in the form of little uranium dioxide pellets. And you have hundreds of those stacked into nuclear fuel pins, which are about the width of your little finger and 4 meters in length. Hundreds of those fuel pins are then assembled in nuclear assemblies, and hundreds of those assemblies are placed inside the core. In between all these fuel pins and the fuel assemblies, there is space for water to go through. As the water rushes in between them, it extracts the heat that is generated inside the nuclear fuel from fission. So the water is never directly in contact with the nuclear fuel. It is separated by a metal thin tube, the nuclear fuel pin, but it extracts the heat that is generated inside the fuel. Once the water becomes hot, you can raise steam with that water, and then the rest is the same.
But when technology fails, or radiation remains in the atmosphere, the fate of millions are thrown into jeopardy. March 28, 1979. a malfunction occurs at the 3 Mile Island nuclear power station near Harrisburg, Pennsylvania. No deaths or serious injuries are attributed to the meltdown at 3 Mile Island, but it was a warning of worse to come. Less than a decade later, another high-profile accident occurs, this time at the Chernobyl nuclear power plant in what was then the Ukrainian Soviet Socialist Republic. April 26, 1986. A routine safety test is carried out to determine how long cooling systems will continue in the event of a reactor shutdown before supplementary power is restored. As the operators conduct their test, they decrease reactor power to a level that quickly renders the RMBK Soviet reactor unstable.
Even in the day, at the time, most of the world had criticized the reactor for being unsafe. It was known that under certain conditions, admittedly fairly obscure operating conditions, the reactor could be unsafe. It didn't have those natural feedback mechanisms, which are laws of physics that we rely on to achieve a controlled chain reaction. And that's exactly what happened the day of the accident. The operators had removed all sorts of safety features, had done lots of things against protocol, had done things that were thought actually unthinkable of, such as removing every possible control rod from the reactor. But yet that was allowed. A proper reactor design should never allow for that to be possible.
As the core begins to melt, tons of radioactive waste billows into the atmosphere. 2 Chernobyl operators die that day. 130 workers and first responders are hospitalized with radiation. 28 die in the days soon after. 14 die later from radiation-induced cancer. 120,000 people are displaced in the immediate aftermath. A spike in childhood thyroid cancer follows. 4,000 deaths in Soviet states and between 9,000 to 15,000 deaths across wider Europe were attributed to Chernobyl. The disaster and resulting political fallout is later described by Soviet leader Mikhail Gorbachev as one of the factors in the dissolution of the Soviet Union.
There is agreement, however, on both sides of the nuclear argument post-Chernobyl. It must never happen again.
The Cold War kick-started a battle for technological dominance between 2 superpowers, igniting the nuclear age.
The Soviet Union and the United States were engaged in the Cold War, which began as a political and ideological struggle. By the time it was over, the United States and the Soviet Union had created 98% of the nuclear warheads.
Since the conclusion of the Second World War, the United Nations has estimated that as many as 130,000 nuclear weapons have been built. A power balance that continues to shape the global political landscape long after the Cold War thawed.
The number of strategic nuclear weapons has been limited and decreased by all these treaties, and so right now we're maybe 10 times lower than we were in the end of the Cold War. That's a good thing. Although on the other hand, maybe not so good, because this makes nuclear war more plausible, because when both sides together had about 70 to 80,000 nukes, everyone understood that when such a number of nukes are actually detonated in different parts of the world, that's the end of it.
So what I liked about the Cold War is everybody had the same playbook. They could see the futility of nuclear weapons. So I think nuclear weapons stabilized the Soviet Union and the United States at the end for them to get rid of the arms race, and it probably prevented the outbreak of a general nuclear war or World War III.
Nuclear power fueled the ideological battle for supremacy. It helped launch humanity into space and unleashed a potential energy solution for the future. And it made us certain that above all else, mutually assured destruction is something we must strive to avoid.